Let me get this recording started here. The first one. So what's the slope of this line?
The slope of the line is 5.
Okay. So another line that's parallel to that would have to have a slope of...
Negative 1/5.
No, that's perpendicular.
Parallel.
That's my next
so it would
question.
also be 5.
Right. The parallel lines have the same slope. Perpendicular lines have the negative reciprocal. And you always have to do two things to get the perpendicular. Change the sign and make it reciprocal.
Okay.
Okay. Try to get this so I got each one at the top. What clearly, I don't want to hide the answers. Let's just take a peek at the answers to see what kind of answers we might have. And then, what do we know is always going to be the first step of a problem like this?
To factor?
Yeah. And that's a quadratic, that's a quadratic, quadratic, quadratic. So we got a lot of factoring to do. What's the actual first step, though? Instead of dividing, what are we going to do?
Flip the bottom and multiply?
Flip and multiply. This whole thing is the bottom. Okay? So when I have this thing divided by this thing, it's the same as flipping this thing on the right and multiplying.
Okay.
Okay? All right, let's start by factoring the top left. What's the first step in factoring? How do you factor 6x squared minus 150?
No, I'm a little fuzzy on factoring.
Okay, the first thing is to look for a greatest common factor.
Okay.
What's the greatest common factor here?
Let me see.
And what I mean by that is, what's the largest thing I can divide both terms by evenly?
6.
Correct. That's the greatest common factor. Okay, so when I factor this, now what am I left with?
X squared minus 25.
Okay, that's still a quadratic. Can I do anything with x squared minus 25? Do you know how to factor that?
Yeah, wouldn't it be x plus 5x minus 5?
Yeah. X plus 5, x minus 5. Okay, that's done. That's our top left numerator. What's the bottom? What does this factor in? X squared minus 3x minus 10. How does that factor?
Oh, I don't know. It's x.
Well, you want to practice your factoring, Axman. Only because the ACT is going to have 3 or 4 questions. Well, maybe not 3 or 4, but they're definitely going to have some factoring questions.
Yeah.
This is a bit much because you have to factor 4 things. But one of the things you're going to notice is that once you come up with the top left, you can be guaranteed that one of these things is going to appear in either this denominator or the denominator that it's being multiplied by.
Okay.
So that's a little helpful. But let's go through factoring. Okay? X. What are the signs? And the next step is to figure both signs.
Wouldn't they both be minus?
No, the only way you're producing a minus 10 is how?
With one positive and one negative.
That tells you that it has to be that. And it doesn't matter where I put them in this problem. Okay?
Okay.
And now you want things that multiply to 10 and subtract, because of that right there, to the number 3. Factors of 10 that subtract to the number 3. What are they?
5 and negative 2.
take the larger of those factors, the 5, and
Mm-hmm.
put it with the sign of the middle term. So the 5 goes there. Okay, the 3 or the 2 has to go there. So now I'm going to go over here and write x plus 2 times x minus 5. And one thing you've probably already noticed is we've already taken like a minute or two, although I'm taking longer because I'm explaining stuff. But now we're going to multiply this, and the next thing we need to deal with is the thing that's going to be on top after we flip. First step
is to choose the signs.
No, first step is to see if there's a greatest common factor.
Oh.
Because that's going to make the whole problem easier. And it's going to make factoring the rest of this easier if we take out a greatest common factor.
So the greatest common factor would be 2.
Okay, leaving
X squared minus 4x minus 12x minus 12, sorry.
12. Okay, now factor that into two things.
Okay, so it would be x minus and then x plus.
Good, that's what you should do as a first step always. Now
then,
we're on the last step.
And then it would be 6 and negative 2.
Well, just 6 and 2.
Yeah.
Okay, in other words, you're looking for factors of 12 that subtract because of that minus sign to the number 4. Well, that's
Okay.
6 and 2, and now the rule is take the bigger factor and put it with which sign?
The one in the middle.
Which is this one.
Mm-hmm.
Okay, so now we've done that. Now we only have one left to do, and that's this top one up here. Let me make some space for it. Now, if you ran into this problem on the test, even though you know for certain you could do it, there's still a question about how much time should you take on this problem. You don't ever want to take more than 2 minutes or 3 minutes max on any problem the first time through. We're probably getting close to that mark. The thing is, this problem is going to solve itself really quick. Okay, what's the next step here?
X plus, x squared.
Factor out a greatest common factor, which is 3.
Minus x, and then minus 30.
Okay, so now the last thing to factor is that.
And that would be x plus x minus, and then it'd be,
For clues, look around. What do we have everywhere? 5s, 6s, and 2s.
So it would be 5 and 6 probably.
Okay, where does the 6 go?
With the negative.
Okay, and the 5 goes here. Now, when I said it's going to end quickly, here's why. That x minus 5 cancels with that. That x minus 6 cancels with that. That x plus 5 cancels with that. That x plus 2 cancels with that. And the only thing we're left with is 6 times 2 divided by 3.
4.
So
Right.
this is kind of a classic problem in the sense that if you were good at factoring, you would know that you would be able to get this right 100% of the time. If your life depended on it and they gave you an hour to do it, you're getting it. Okay.
Right.
Problem is, do you want to spend 5 minutes doing that, especially early? I would not. If I were you and I got to this problem, and I would use like a single check mark and a double check mark. Double check mark for extra hard problems that you don't really have a clue as to how to do. Single check mark for problems that you think you can do if you spend enough time on them. Okay?
Okay.
All right. Let's kind of use that. And you're going to have to pace yourself when you take this test. In other words, you don't want to get to problem 30 when there's 30 minutes left. That's too
Yeah,
slow.
for sure.
That's the right pace, but you want to have some time left over to go back and do the problems you check marked. Okay?
Okay.
All right. Here there's two conic questions on the test. And as long as we're talking conics, well, let's see. Let's draw a picture of this instead of talking about conics yet.
Okay.
The circle has its center at the origin and it has a radius of 3 root 2. How should I start drawing this circle? Even said,
Probably.
if you start from this point, well, where is that point? That's that point right there. 3 root 2 comma 0. Okay, so we're looking at a circle like this. Now it says, if you trace the circumference from the point 3 root 2 to minus 3, 3, where is minus 3, 3?
On the other side.
Okay, there's the minus 3.
And then up.
Actually, there's minus 3. Notice that minus 3 is not as big a number as 3 root 2. Root 2 is about 1.4. So this goes all the way to about 4. This is going to go to minus 4. So this point right there is minus 3 comma 3. Okay? So they're saying, what is that angle? Well, let's say you can't figure that out. Okay?
Okay.
And you had to guess.
Okay.
What would you guess? Let's talk about making an educated guess. I'm going to show you how to figure it out, but I want you to be able to make an educated guess when you need to.
Okay.
Can it be 45 degrees?
No.
Can it be 90?
No.
Okay, so it's either 105, 120, or 135. Our picture suggests what, if you had to guess right now?
I would say like 120.
Okay, to me, the way I've drawn it, now that might be accidental, is it looks like it's 45 degrees more. So I would guess 135. But
Okay.
figure it out. Let me drop the vertical here. And what we have to figure out is this angle, theta. Okay? Well, that angle theta, this side of the triangle is 3. This side of the triangle is 3. What is that angle theta now? In other words, here's our right triangle. This is theta. This side was 3, that side's 3. What kind of triangle is that?
An isosceles?
Exactly. What do you know about isosceles triangles? They have two similar sides. What else?
Two of the same angles?
Yes. If that is 3 and that's 3 and that's theta, that has to be theta also. In other words, the angles opposite the similar sides are also the same. So
Okay.
that's a right triangle. What is theta?
45.
Right. And so the line that you trace is 135 degrees.
Okay.
Now, they didn't actually tell you which direction. They didn't say counterclockwise, which they should have. But luckily, they didn't put any answers that would represent the angle going that way.
Right.
Okay, that was a fairly tough one. I don't know if that was geometry or trig. Could have been, either subject. There's going to be 4 trig questions on the test. So you want to make sure you know your basic trig. They're not hard trig questions at all. You have to know very few identities. But you do have to know your reciprocal identities for sure. And you have to know sine squared plus cosine squared equals 1.
Okay.
Okay. Two similar triangles. What's similar mean?
That they have this same, like, basic shape, kind of. I don't know how to describe it. Like,
Well, the best way to describe it is they have the same three angles.
okay.
Okay, in other words, that angle is equal to that angle, and that angle is equal to this angle. The side relationships can be anything you want. As long as you have the three basic same angles, you have similar triangles. And they're telling us in this one that they're both 30, 60, 90.
Okay.
So this is 30, 60, that's 30, 60. And they're saying if the side opposite the 60-degree angle is 2 root 3 in the first picture, and root 3 in the second triangle, let me reverse these so it makes sense. This is going to be 2 root 3. This is going to be root 3. Ooh, this is a tricky one. How many times larger is the area of the first than the second?
Huh.
What is the linear similarity ratio? By that I mean you take one side, the common side, the side that's in common, proportional to the other one, and divide those to come up with the similarity ratio.
Is it 2?
Yes. Similarity ratio is 2, but it's all that means is that every side is 2 times the other side. Okay, so if this were x, that would be 2x. If this were y, that would be 2y.
Okay.
Now what it's looking for is what is the relationship between the area of this triangle and the area of that triangle?
Is it 2?
No, it's 4. It's 2 squared. Because
Okay.
we're going to a linear measurement to an area measurement. When you go linear to area, you square the ratio. When you go linear to area to volume, you cube the ratio.
Okay, that makes sense.
It depends on whether you're talking one linear, area, or volume. But, yeah, in other words, I know that that side is 1, and this is 2, just because I know my 30-60 unit triangle. Okay, so this side has to be 2, 4, because the similarity ratio is 2 to 1. Now notice how we find area. It's 1/2 base times height. Well, that gives this area square root of 3 over 2. This one is 1/2 base times height. That one becomes 2 root 3. Well, that is 4 times that.
Okay.
Even though the similarity ratio for the linear was 2 times.
Okay, cool. That makes sense.
Solve the system of equations. Now, what I'm kind of noticing in this test, I don't know where you got this test, but it seems to be a little harder questions than the tests that I have in my computer. Although if you focus on the last 30 problems on my test, they're harder. But some of these are fairly difficult for how are you going to solve these two equations?
I don't know. Maybe plug them in and see.
Well, you got two choices. You can do by substitution or you can do by elimination.
Okay.
Which one do you use when the equations look like this?
I don't honestly remember.
Okay, it's elimination. It's part of the problem. Part of the problem with taking your ACT as a senior is it's mainly algebra and geometry. Okay?
Mhm.
And
I mean, I already took it as a junior once too, but I'm just
well,
taking
but
it
it's been
again.
a while. In other words, it's a problem common to a lot of seniors, is especially geometry. Some of them, it's been 3 or 4 years since they had geometry.
Yeah.
Geometry problems can be particularly challenging. But
Yeah.
this is a straight algebra problem. Whenever I have two equations, I can either do them by substitution or elimination. Now, these are very, very close to standard format. That one's not in standard format, but if I switch the x and the y, it is. In other words, if I write it in standard format, I put the x first, now everything lines up.
Okay.
Okay? How do I solve that system of equations right there? By elimination. In other words, think elimination. When you see it sitting up all nice and pretty here with the x's under the x's and the y's under the y's, elimination means you need to eliminate a variable. Now, the
Okay.
other thing that you're always allowed to do with equations is add them or subtract them.
Okay.
Well, if I were to immediately add these, no variable goes away. I get 15x, I get 2y.
Right.
Trying to get rid of a variable. So the other rule of algebra is you can do anything you want to one side of the equation as long as you do it to the other. So what kind of manipulation can I make on one of these equations such that when I then add them together, one of the variables is going to go away?
Plus y to the top one.
Not plus y. In other words, I'm not going to eliminate the variable from one of the single equations. If I added y, it would just make that y go to the other side. It wouldn't get rid of it. I'm trying to get rid of it. What if I multiply the top equation by 3, both sides? What do I get?
30x minus 30y equals 90.
By 3.
Oh, 3y minus 90. I mean, equals 90.
Okay, now that becomes my new equation 1. Now notice what I can do. What can I do now, and a variable will get eliminated?
Oh, you could add them.
What do you get after you add them?
35x equals 140.
Making x equal 4. It's okay. You should actually have a calculator in front of you when we're doing these.
Yeah, I have one. I just needed to type it in.
Okay, that's fine. Now, the reason I opened up the test to look is that typically, once you've solved for x, you got to go back and substitute it into one of your equations to solve for y. Okay, that's the standard way to solve for both parameters.
Mm-hmm.
Okay, and you could do that. You could pick any of these 3 equations, substitute x equal 4, and then you'd be able to solve for y. But this problem is they're giving you a little bit of a break.
Yeah.
What's the answer?
D.
D. We don't have to go in and solve for y. They just saved us 30 seconds by giving us only one answer that had an x coordinate of 4. And it's worth looking at that rather than to blindly plow through the algebra. In other words, once you get to x, a lot of people would just keep going and solve for y as fast as they could, rather than look at the answers and see maybe x is all we need. I can see that they're making these particularly tough early. So I wouldn't worry that we're taking well in excess of 1 minute to do each problem.
Right.
They're giving you the hard ones here.
Mm-hmm.
So there's z, there's y. What is k if k is equal to that? How do I figure out what that is?
I have no idea.
Okay. What does that mean?
Like just z to the negative 1. I don't really know.
Well, negative exponents have a very specific meaning, and it has nothing to do with negative numbers. It means that. If I said z to the minus 2, then it would be 1 over z squared. In other words,
Okay.
all you do is you reciprocate it and use the positive exponent.
Okay.
Okay? So now what does this all become? What's y? That's already in the numerator and should stay there. So let's start writing what k is going to be.
1y over z.
Correct. They tell you what y is. So what's y?
X squared plus 3x minus 4.
Over z, which is x squared plus 4x minus 5. Now again, we're looking at two quadratics, and maybe we need to factor them, maybe we don't. Let's check our answers. Do we see that answer anywhere? No. That means we need to factor it. Okay? So factor the top.
It would be x plus 3x minus 4. I mean x minus 1.
Okay, remember the factors have to multiply to 4.
Oh, yeah, 4 minus 1.
Okay, and the bottom?
Would be x plus 5x minus 1.
Simplify.
Cross out the both x's minus 1, so it would
There's
be
your answer. And that's k. That is on there. Okay?
Okay.
Alright, so you can see already that factoring is something you're going to want to be good at. Especially every factoring problem they've given us is a first order factoring problem. In other words, it was one where the coefficient of the quadratic term is always 1. The only time it was more than 1, we got rid of it by taking a greatest common factor out. Okay, so the only quadratics that you have to factor, they're always going to be what I call first order factoring, where you don't need a California method or a diamond method. You just need those simple 3 to 4 steps that I've taught you for factoring. As long as there's no coefficient in front of that, factoring is actually quite easy. It's only when there's a coefficient that it can become tough. But I don't think they're going to give you problems like that on the test that require you to factor something that has like a 3 or a 4 in front of the x squared.
Okay.
Let's look at this.
They are giving us hard problems to start with.
They are. But don't be too intimidated by this. Shaded region problems are always what? What kind of? Like the
trick.
They're always not trick. They're always subtraction problems.
Okay.
All shaded region problems. We don't have the math yet. That's calculus. Are you taking calculus this year?
No, I'm taking statistics instead.
Okay. We don't have the math. We would in calculus, but we don't have it in non-calculus to figure out the area of this region. However, we do know that this whole thing is symmetrical with this whole thing, and they're giving us the area of this is 7.5. So we know the whole area of this is 7.5. Minus the area of that triangle would give us this area that's black shaded, right?
Yeah.
So all we have to do is figure out the area of that triangle. Okay, and that triangle is comprised of that segment right there. So if we can figure out the coordinates of that triangle, in other words, what's that point there and what's this point here, we'll be able to figure out the area of that triangle, and then we'll be able to answer their question.
Okay.
What are the coordinates of the x-intercept of that original equation?
4, 0.
Notice that when I ask for the x-intercept, what's y?
0.
That's the secret. And here's the equation of that parabola. Okay? So to figure out what this point is on the x-axis, I know the y is 0, but I don't know what the x is, and I need that because that's going to be the base of my triangle. So I set y equal to 0 because I know that it's 0 at this point. And then I solve the equation. Solve that for me.
Goodness. 0.
What's the first step? Let's solve it step by step.
Is it,
Trying to isolate x.
yeah, so you would multiply by 2 on each side.
Okay, I find it easier if you add the 4 first. It's not going to make much difference, but if we add 4, we get this. Now get rid of the denominator, so you get this. Now what? Once you get that, what's x equal to?
The square root of 8.
Okay.
Plus or minus the square root of 8.
Good, I like that. 95% of my students forget the plus or minus, but in this case, it's all plus, because we're looking at, excuse me. In this case, we can tell that it's plus square root of 8, because I'm on the plus side, right?
Right.
So it's not minus. Okay. So that's the base of my triangle. Now I have to figure out this point here to figure out the height of this triangle. Well, how do you get the y-intercept? The y-intercept's much easier to get than the x-intercept.
It's already in the equation. It's just negative 4, 0. Right?
Well, it's not really in the equation, but the y-intercept means x is 0, right? So all you have to do is plug in 0 for x. It usually makes that entire term go away, and y equals negative 4. So yes, now I know the dimensions on this triangle. That's 4, and that's root 8. What's the area of that triangle?
Hold on.
What's the formula for area of a triangle?
It's really bad that I don't remember.
1/2 base times height. You definitely want to review all your geometry formulas that you're going to need to know.
Okay.
Areas of triangles is right up on the top of the list. Areas of circles, circumference of circles, that's next. You want a little sheet of paper that, or flashcards or something that you can drill yourself with to remember these. Because at a minimum, you need to be able to figure that out. So what's the area of that triangle? If it's 1/2 base times height.
It would be times 4. It would be 5.68 and 5.65.
Okay. Normally I would argue with the fact that you converted it to decimal, but in this particular case, we need it in decimal. Because we're going to have to do what next? In other words, if this area is 5.65, and we're trying to figure out this area, and we know the area of the whole thing, what do we do?
Subtract 5.65 from 7.5.
What do you get?
1.85, so it's B.
Yeah. Yeah, they're giving you problems that are, from a tutoring perspective, they're all 5 or 10 minute problems.
Yeah, my this is my homework for my ACT tutor this week. So.
Yeah. In other words, I don't know. There are some basic things you really need to practice on, and I'm not sure that it's in your best effort to be working on nothing but super tough problems. Just make sure you go through all the formulas you're supposed to know, like area of a triangle, area of a circle, things that I just mentioned. All right, let's see. Let's look at number 8. And if you don't really know how to start a problem like this, draw a picture. That's always a good way to start. Okay? We have a point P that is at minus 5 comma y. Well, there's minus 5. It's somewhere on this vertical line. We don't know where. We'll just make a point right there, P. It could be above the x-axis. It could be below the x-axis.
Mm-hmm.
If the length of the line segment from the origin to point P is 13, what is the value of y if y is greater than 0? Now you have a geometry problem to solve. In other words, this distance of that triangle, in other words, it all comes down to figuring out triangles. If there is one thing that will improve your ACT math score more than any other, it's being able to quickly solve all right triangles.
Okay.
Okay? If you can do that, you're going to get 5 or 6 problems correct and quickly. But you got to be able to do it quickly. Here's our right triangle, and we're trying to solve for that measurement right there.
Mm-hmm.
How do I do that?
You square both of them and then subtract 25 from 169.
Yeah, do it for me rather than describe it.
Okay, so 13 squared is 169, and then minus 25 is 144, so it's 12. Okay,
cool. And that is the second most basic Pythagorean right triangle. In other words, there's 2 that it's really worth knowing because then you don't have to go through the math. And that's the 3, 4, 5 and the 5, 12, 13.
Mm-hmm.
3/4 of the right triangles they're going to put on this test are going to be one of these 2 triangles.
Okay.
Okay, or a multiple. When I say 3, 4, 5, it might be 6, 8, 10. Similar to our 3, 4, 5. Or it might be 50, 120, 130. Okay, but these are 2 right triangles that it's definitely worth recognizing. You save yourself all kinds of time in math. Okay? Okay, let's draw our circle. You don't always have to draw a circle, but they say an isosceles triangle is inscribed in that. Well, notice that I could inscribe multiple isosceles triangles in that circle. It doesn't have to be the way I drew it.
Right.
It could be like this. Okay? So we know something, but it's not definitely definitive what it is. Other than that's A, and this is B. What of the following must be true? Side A is greater than side B. B is greater than the two smaller sides combined. B is less than 0. B is greater than A. A squared plus B squared equals A squared.
I think it's C. B is greater than 0.
That actually says B is less than 0.
Oh. Oh.
Well, B can never be less than 0.
No.
So there's one answer we can definitely rule out. It's that.
Yeah.
The thing is, well, does A have to be greater than B?
No.
Not if I draw it like this. I don't think. I think A is less than B if I draw it like that.
Right.
Does B have to be greater than 2A? Well, no, because clearly, in the way I've drawn it here, B is not greater than both of those added together.
Right.
That's not true. B is less than 0 is never true. B is greater than A. Well, no, obviously I can draw it like this.
Right.
B is not greater than A. A squared plus B squared equals A squared. That would indicate that B squared has to be 0.
Yeah.
Right? In other words, if I go to solve that, I get B squared equals 0.
Yeah.
B squared clearly is not 0. So the only thing I can figure out they did here was they made a typo and they meant to put B is greater than 0, perhaps. I don't really know what's going on with this problem. But all 5 of the answers not only don't have to be true, they're sometimes true. Yeah, sometimes A is greater than B. Sometimes that's true. That's never true. Sometimes that's true. And that's never true. So you have a bunch of conditions there. I don't know. Maybe they meant to say which of the following is never true. And that would be C. And then you would have an answer, it would be C. So something funky is going on with that problem. I'm not sure what it is.
Okay.
You can never overrule typos, though. I run into typos quite a bit in some of these. Okay. Another tough question based on speed, distance, and hours. In order to solve this problem, you need to know the master function that describes speed, distance, and time. What is it?
Isn't it distance equals rate times time?
Dirt.
Oh.
That's how I remember it.
Okay.
In other words, the only thing that matters is you get the order right.
Mm-hmm.
And dirt is a great way to remember that. You'll never forget it again. Okay? So, a couple took a trip to their hometown and back at a rate of this speed and traveled for this amount of time. If they traveled a total of 3,000 miles round trip, what was their average speed? So how do I use this equation to answer that?
It would be 3,000 equals x plus 5 times x minus 2.
That gives me the following. Well, you tell me. Multiply those two together.
X squared plus 5x minus 2x minus 10. So it would be x squared plus 5x minus 2x minus 10.
Which is, and then combine your two middle terms always.
Mm-hmm.
Okay, so now I got that. And notice that their average speed is x plus 5. Well, how am I going to solve this problem? In other words, if I can solve for x, I can see that they went there and back at an average rate of x plus 5 miles per hour. So once I get x, I have my answer.
Right.
How do you get x when you have that?
I don't know. I would
Always set one side equal to 0. And when you have a 3-term quadratic like this, you just get both sides like that. In other words, I subtract 3,000 from both sides.
Okay.
Now, you know what? Talk about a problem that is easier solved by back solving. This is it.
Just plugging in numbers?
Well, that's going to be hard to factor.
Right.
We're looking for two factors that multiply to this big number and subtract to the number 3.
Mm-hmm.
Well, I don't know how to do that. Maybe your calculator, you know how to do that. But other than going through the quadratic formula, which is long and laborious and big numbers make it much harder, there's a much easier way to do this problem. Let's talk about it, because I've never seen a problem that you can definitely solve by back solving, but it's hard to solve algebraically. Okay? If distance equals rate times time, and they went 3,000, that also means that rate equals distance divided by time. And they want the average rate. Well, we know the distance is 3,000. And we know the average rate was x plus 5. So if x plus 5 is equal, whenever you're back solving, always start with the second lowest or the second biggest. This case, I'm going to start with the second biggest. Okay? If in other words, we can figure out, hold on a moment. Yeah, I'm trying to get away from that quadratic. I know what I'm trying to say here. Let's assume 65 is the right answer.
Mm-hmm.
What's x if 65 is the right answer?
60.
Correct. So let's see. Let's plug it in. So that would mean that 3,000 divided by time, well, if x is 60, time is 58 hours, right?
Mm-hmm.
Is that equal to 65?
Let me see.
I can tell you it's not.
Oh, okay.
Because 3,000 divided by 50 would be 60. So if I increase the denominator to 58, I'm not going to move this up, I'm going to move it down.
Yeah.
So 65 is not the correct speed. Do I need a lower or a bigger speed?
A lower speed?
I think lower, but I wouldn't stake my life on it. Okay?
Right.
Let's see. Okay, 3,000. If I next go to the second lowest, which is what you want to do, go to 60. If 60 is their average speed, what is x?
55.
Okay, 55 minus 2 would be 53. Does that equal 60? No again.
Okay.
In other words, this number came up less than 65. This number comes up, well, 5 goes into that 60, so 53 is going to go into less than 60. So in the first case, I came up with a number that was too small. In other words, 3,000 divided by 58 is less than 65. I thought that that meant I needed a smaller number, so I went to the smaller number 60. I tried that, and I still came up with a number too small. What is my answer? And I don't have
70.
I don't have to do any math. No. When I tried 65, I got a number that I thought meant that I had to go smaller, so I went smaller, and I get a number that still looks like I got to go smaller.
Oh, so 58.
58 is the answer without doing any math. Okay? And this is a case where you would go ahead and answer 58 without doing the math, because it's just a waste of time to do the math. But just to verify for you that that's the case, we have 3,000. If 58 is the answer, what's x?
51.
Okay, so x would be 53. In other words, x would be 53 if 58 is the right answer. And if I plug in 53 there, I get 51. Now, is that equal to 58? And I'll bet it is. If you put it in your calculator, it's going to be very close. And you can tell they say round to the nearest whole number. So,
yeah, it's 58.
Yeah, if I divide that by 5, I can only divide it in there 5 times. And so it's 5 plus. So that's the way to do that problem. And gosh, that may be the only way I can think of to do that problem. Merely because that quadratic is so hard to solve. You can solve it algebraically, as we started to, but they went out of their way to make the distance so long that it's going to be a really hard quadratic to solve. And it's actually a problem done easier by back solving it. Start with an answer, assume it's correct, plug it in, see if it is. Frequently, if it's not the correct answer that you start with, you'll know which direction to go. You'll know 90% of the time, you'll know you need either a smaller number or a bigger number. Now, we started with 65. If we'd have known we needed a bigger number, I'm done. That means 70 is the answer. So this knowing which direction to go is pretty critical. But even if you don't know which direction to go, you can do it kind of the way we did it. We thought we had to go down. We tried 60, and it still looks like we went the right direction. We just didn't go down far enough.
Right.
Okay. Let's try one more here at least. Never underrate the value of back solving. I love back solving. I'm surprised that it took us 10 problems to find one that you had to use back solving. But it's not always a case of having to use back solving. It's usually the easiest way to do it, by a lot. It's almost always easier to back solve if a problem can be back solved than it is to set it up algebraically and try to solve it algebraically. But in that previous problem, the most important thing, you couldn't even begin the problem if you didn't know dirt. Okay? If you didn't know D was equal to RT, you have no shot. But even knowing that, it was still a hard problem. All right.
Okay.
We can interpret this, and you can say, calculate what John's paycheck is. So they're giving you all of the conditions on how much he gets paid. And they want you to give them an expression which determines the dollar amount that that's going to be equal to, given a certain D and a certain H.
Okay. So, so 1.5. Is it 1.5 H minus 40?
Yeah, because in other words, the common mistake here would be 40 times D plus 1.5 times H. But you don't get paid. H is the total hours worked. You only get paid for the hours worked greater than 40 at this time and a half rate. So those hours are H minus 40. And so there's the expression. Is that on there? Here's another case where before you dive in and start simplifying, see if that's on there.
Okay.
I don't see it on there. Do you?
No.
Okay. So what is on there that looks close to that? Just a second. If H is greater than 40 and John worked H hours this week, calculate what his paycheck is. Well, let's try to simplify this. 40D plus 1.5H minus 60. We forgot, this is not the correct original expression. It's 40 times his rate of D dollars per hour plus 1.5 times the number of hours times D again. I need another D there. In other words, this is merely the number of overtime hours he works. He gets 1.5 times D for each of those hours. So this is the correct expression. And now when I simplify, it is going to simplify. In other words, I check and see if that's on there, and it is not. So I go to simplify. I get 1.5 HD minus 60D. And now I got a 40D and a minus 60D, which is minus 20D plus 1.5 HD.
Okay.
That is on A. That's A.
Okay.
Okay. Yeah, in other words, there's 40 hours and he makes D dollars per hour. And there's this many times of overtime hours. And he gets 1.5 D for each of those overtime hours. So that's why you have to multiply this second term by D also.
Okay.
Then just simplify. Once you simplify, you get the answer they have on there.
Okay.
All right. Let me do one other thing here before you go. I'm going to copy and paste this into the chat window. I want you to click on it. Hold on. You see it in the chat window on the GoToMeeting?
Yeah. Just clicked on it.
Click on it. Save it as a favorite.
Yeah.
Okay? And here's what it's going to allow you to do. You go here and you click on Book Now. You get shown my entire availability. If you're looking for a 1-hour online session, click that. And it's going to give you a calendar. And if you click on a given day, it will tell you all the times I'm available and when I'm not available, basically.
Okay.
And that's going to be a far easier way for you to schedule sessions than doing it the way you did it. In other words, when you text me and you say, are you available, it's really difficult to tell you my availability. It's a bunch of hourly slots. You know what I'm saying?
Yeah, for sure.
By far, the easiest way is for you to go to this site and see my availability for whatever day you're interested in. Not only that, but you can make the appointment on here. In other words, click on one of those, enter your first, last name, and you've made that appointment. You don't even have to contact me. So I'm going to click out of that. But this is the site to go to, and just click on that book now. I wonder, I actually probably could have given you that, but I don't think that would let you get back. I don't know. But just go to that page and click on book now.
Okay.
And then you can make future appointments if you so desire.
Okay, sweet.
And I'll hold on to this. If you want to get back to this, we can start at question 12.
Okay, sounds good. Thank you so much.
All right, Aspen. Have a good one.
You too.